In this video, I will be explaining how to find the determinants of a 2x2 and 3x3 matrices. Problems similar to the ones in my lecture can be found in Chapter 8. I picked this chapter because I did poorly on the test, but creating this lecture has helped me to finish my test corrections, and hopefully I'll do better when I retake the test. First, I'm going to show you how to evaluate the determinant of a 2x2 matrix without a calculator. For a 2x2 matrix, the determinant is calculated with this formula. A, B, C, D equals AD minus BC. If you replace those variables with actual numbers, the matrix will look like this. -7, 7, -5, -7. Basically, you're going to cross multiply. Going back to the formula, A multiplied by, this is a D, A multiplied by D subtracted by B multiplied by C will give you the correct answer. So, -7 times -7 gives you a positive 49, and -5 times 7 equals -35. 49 minus -35 equals 84. Subtracting a negative is the same as adding a positive, so this is going to change to a positive, and it's 84. Finding the determinant of a 3x3 matrix is a little more complicated, but after going through each step, I'm sure it'll make sense. The determinant is the difference between the products of the up and down diagonals of a matrix. So here's an example problem. A equals 4, 2, 1, -1, 5, 2, 5, -7, 10. The first step is to extend or copy and paste the first two columns of the numbers. So on this side, you're going to write 4, 2, 1, -1, 5, and 2. Then you're going to multiply along the down diagonals. That's going to be 4 to 5, and then 5 to 10, -1 and 7, and 1, 5, 2, and 2. So 4 times 5 times 10 will give you 20 times 10, which equals 200, and then -1 times -7 times 1 is going to be 7 times 1 equals 7. Oh, this is 200, sorry. And then this is going to be 5 times 2 times 2 is 10 times 2, which equals 20. Then you're going to add up your answers. So 200 plus 7 plus 20, that gives you 227. And then you have to multiply the diagonals going up. So you're going to have, let's see, 1 and 5 and 5, 2 and 7 and 4, and 10 and 2, and -1. So if you write that down, -1, 2, and 10, -2 times 10 equals -20, and then you have 4, -7, and 2, -28 times 2 equals -56, 5, 5, and 1, 25 times 1 equals 25, and then adding up -20, -56, and 25 will give you a -51. And lastly, you subtract the answer you got from multiplying and adding the down diagonals by the answer you got from multiplying and adding the diagonals going up. So the formula for that is actually going to be D1 plus D2 plus D3 minus U1 plus U2 plus U3. So you have 227 minus a -51, so that gives you 227 plus 51, which equals 278, which is the value of the determinant. And the last thing I'm going to cover is how to evaluate the determinant of a 3x3 matrix using a calculator. Last thing I'm going to cover is how to evaluate the determinant of a 3x3 matrix using a TI-89 calculator. If you're not already on this home screen, you can press the purple Apps button and it'll take you here. You want to select Data Matrix, press Enter, and then you're going to go to number 3, New. For type, you're going to put Matrix, folder, main, variable, I'm going to pick N1, so alpha, N, make sure it's off alpha, 1, row dimension, 3, column dimension, 3, and then I'm going to press Enter. And here are your columns. I'm going to use the same numbers from the last matrix, so it was 4, enter, -1, enter, 5, enter, 2, enter, 5, enter, -7, enter, 1, enter, 2, enter, 10. And now that's entered, you're going to hit the home button and you're going to type in determinant, which is you're going to need alpha and where's D? D, alpha E, alpha T, parentheses, and the variable I used, it was N, so make sure it's on alpha again. So I go to, that's I, N, off alpha 1, and it should be 278, which was the answer we got doing it by hand. And there it is, 278. And that's how you solve 2x2 and 3x3 matrices.